All right. So with regards to, so let's talk about the final exam. So for the most part, the final exam is going to be a lot like exam 2. Okay? So cover a lot of the same bases of exam 2. We're talking iterating over over lists, right? So we had a couple of questions on the exam that were like, oh, let's look at a list of lists and find stuff in the list of lists. Oh, let's count how many things in a list follow this attribute, right? Those kind of questions you can expect. And you can expect them to be around the same difficulty as what was on the exam for that attribute. Part of, I think, what the exam made the exam difficult is that students have trouble pacing, especially with regards to being on a laptop and then having to fix errors and that taking time. Yes, no? That error, or perhaps I made it one question too long. So we have our lists. So we have our lists question. We have our question on, we are definitely going to have a file reading question on there, okay? And definitely going to have a question on Monte Carlo, okay? I've got a Monte Carlo approximation question in mind. I love it, and I'm going to use it. Now, what's to note about the final exam is that, you'll be choosing, you'll have to solve X out of Y questions. In other words, I'll give you maybe something like, again, I haven't figured out the exact numbers. You might have to solve 4 or 5 questions out of like 7 questions that I present you. In other words, you get to choose which of the questions you're most comfortable with, right? So the reason I do this is that it has worked for the past couple of semesters. I also, by the way, not that people try this, but if you do try to game the system, which is that like you answer all of them and want me and try to convince me to take the best ones that you did, no, I'm just going to do them I'm just going to do them in order that, from top to bottom. And as soon as I've checked off the requisite number of questions, those are the questions you've answered. So if you answer more than one, I'm just simply going to go top bottom. Just simply that helps me deal with that having that rule means it's fair, and I don't have to think about it later if that comes up. It hasn't come up, but I've seen it that kind of thing happen in other circumstances. So anyway, we've got list, we've got file reading, we've got a Monte Carlo question. So definitely those kind of questions on there where you have to read a list. I will go, but let's see, what else do we have? Definitely a question on turtles, okay? Definitely a question on turtles. Either giving you a figure and asking you to write a program that draws that, right? Or giving you a program that draws a turtle and asks you to figure out parts about it, okay? Overall, what the questions I've asked in the past have been pretty well received on that one, and I thought they've done a great job of testing what I need them to test. One of them is what we're going to be going over today, regex, which is short for regular expressions. Now, regular expressions formally would come into the formal automata class here, where you talk about discrete finite automata, determinate finite automata, and NDFAs, non-deterministic finite automatas, and then use those to build up to stack machines, context-free grammars, and then use those to build up to Turing machines and Turing-complete languages. It's a very kind of, it's a class where you get basically the formal kind of, the formal mathematics of computer science, where we formally prove what computers can and cannot do. And I do mean like mathematically prove those kind of things. It's a very interesting class. And regular expressions are basically, writing things in a regular language, regular having a special definition here, which is equivalent to these deterministic finite automata, which unfortunately means you miss out on one of the most one of the most amazing tools and one of the most flexible tools that are built into every programming language until or unless you take a completely optional high-level mathematics class, which is amazing and I love it, but no. So over here, I've kind of made the overriding decision that I'm teaching you this because it checks off multiple boxes. First off, it's something to keep us interested in this at this point in the semester. It's completely different, yet does not necessarily rely too much on our prior knowledge. It is also useful for basically everybody who, no matter what your objective is in the class. If you are going into an office job or something, these things will be useful because pretty much everything is got regular expression search features built into it these days. If you're going in, to like accounting or something, this will probably be useful. It's useful everywhere. Anything that deals with text, and you're going to be dealing with text all the time, regular expressions are useful. We'll see about that later. As I mentioned online, also there's definitely going to be a mystery question, which is just a way of making it sound exciting, I guess, or possibly scary. So this question is something I've done in the past on final exams. So it's something I've tried. It's something that works, and it's something that that we will do here. This will be something where I present you with something that is built into Python, either natively or in a importable library. And it's a fairly well-used thing. It's not something you've been exposed to in class, but I'll list, okay, here's the common operations you can do with it. Like if this was me teaching you how to do lists on the fly, it would be I'd say, okay, here's how you do, here's .append to add things to a list, here's, .remove to remove things for a list, those kind of operations, And I'd say, okay, this is what makes this special. Please use it to solve this problem. This kind of base canonical problem that this thing is made to solve. It's not as scary as it seems. Any more detail I would give you would make it, but basically what I'm testing is, can you learn, do you understand programming / Python well enough to take new knowledge that isn't complex and use it? Or isn't any more complex than what you already know? Okay, so once again, we'll be able to. I'll probably have in maybe another list question depending on it, depending on the things. But so a list, and so I'll put that second list question. I'll have a bit more of a formal idea of what I want to do with regards to that next week, But this is generally, but definitely these subjects will be on there. Yes. Yes, they're all going to be weighted the same. That's why I say 4 or 5. If it's 4, each of them will be 25 points. If it's 5, each of them will be 20 points. Yes, they're big high stakes questions, but again, they'll have that rubric over there to kind of guide you to getting to those answers. Okay. Overall, what was people's impressions of exam 2? I haven't had the chance to go and look at them yet. The TAs have been grading it. Was it difficult? Seemed like I had a lot of people who needed extra time on it. Yeah. Felt like it definitely need more time. Mm-hmm. Okay. I'll keep that in mind. What about the trail, that last 5 points? Was that appropriate? Did you find that useful to be able to go back and correct that? Yeah. Okay. That's good. I think I have my last exam or two to cover like tonight, so those will be handled, and then I would be more than willing to kind of talk about it on Discord at that point. Yeah, any questions about the final exam apart from this? Yes. 2 hours. 2 hours on the final exam. I also plan on, just like there was a pre-mastery quiz that I released for extra credit at the beginning of the semester, there will also be a post-mastery quiz, also give you points for extra credit, that I'll be releasing in a day or so. So keep an eye out for that. I will make an announcement, but that's another chance to get a bit of extra points, right? All right. Yes. Yes. Once you're done, you're allowed to leave for the final exam. All right. Yes. And then you. But either you both had your hands up, so you can go first. No, I will take a look at it. It's fairly straightforward for me to. It will be fairly straightforward. You don't have to demo it. Yes. I think it's this room. I will post the details in an announcement. I typically don't post it until like this end of this week or something. Okay, that's when I start worrying about it. Yep. 2 hours. 2 hours for it's the entire final exam session. Yes.
The list of Monte Carlo questions, are they going to be just like on the test?
They'll be just like on the test. Typically for Monte Carlo, it's going to be the game will be a bit more complex. But I can tell you that by complexity, I mean it will I promise you the game that I provide you will literally be able to be played by toddlers. Okay? The game will not be complex in that regard. Yes. Yeah, same idea with the notes. But again, the entire point of Monte Carlo isn't necessarily the complexity of the game, but the, calculating the results. And there's a lot of variation. It could be what is the percentage chance of winning versus how long a game lasts for, how many turns, right? We've looked at various things like that in the PIG assignment. Okay. All right. Other questions about this? All right. So, any questions? No more? Okay. Yes. Yes. Same restrictions and permissions that were on the final exam, that were on the second exam. Yes. Yes. Same permissions and restrictions as the previous exam. All right. So with that, I guess we'll get started on today's topic, which is Florida Man. Who is so for those of you for those of you who are from the U.S., does anybody want to volunteer explaining the Florida Man phenomenon to any of the international students? Anyone? Anyone want to volunteer? Yes. So what is Florida Man?
So, like, news?
Yes.
Okay, I actually have knowledge from Florida, this is really funny to me. So basically, Floridians are known to be really wild and chaotic, and they do the most, like, randomest things, like running around football field in, like, weird outfits, or, like, fighting alligators, or, like, crimes, but, like, not normal crimes, like cannibalism.
Yeah.
Things.
Yes. Do you know why that is?
Because it's the cesspool of America.
That's one explanation. There is that scene from The Good Place where they're talking to one of the characters and says, "You're from," and they're in a bank and there's some like from Florida. Legally, we're not even supposed to be open if you're in here. So Florida gets to be the butt of many jokes in America, particularly because of this phenomena of Florida Man, which is a very interesting phenomena. And the idea behind Florida Man is just typically like put in Florida Man, add your add your birthday into it, and see what see what crazy thing happened. But why, right? I mean, is it really more of a cesspool of America than, say anything else? I mean, because every major city in America is pretty hugely diverse. Yes.
I've seen on Instagram that one kid trying to catch a 20-foot Burmese python. He just goes around the Everglades trying to find the python.
I have not seen that. I've seen, although there's an entire TV show dedicated to the concept of catching Burmese pythons in the Everglades, which are an invasive species there.
I'm going to find it and I'm going to send it to the Disney.
Sounds good. Yes.
Okay, so from what I understand, like the state of Florida has already laxed journalism laws, and that allows for more local news to be publicized and spread across the
There we go.
general, like America in general.
That is around the correct answer. Yes, which is that and it's less about the journalism laws and more about the open books laws there, which is to say that various laws have various states have different laws regulating what goes on, with police information. Namely, like how readily available is arrest information, how readily available is other information available, and how accessible is that public. Florida, being the sunshine state, loves its sunshine laws, which basically say, hey, you get to look at the government's kind of business here about how they arrest people and stuff. And you can have various debates as to various qualities of different policies or whatnot, but regardless, there's a lot of, that is one of the many factors behind the entire idea of Florida Man, which is that, the meme, due to a confluence of factors, including the public record laws, giving journalists fast and easy access to police reports. There you go. The relatively high population of the state. You need a lot of people to have, you need more people for more bizarre events to happen, because if you have less people, there's less stuff going on, therefore less bizarre events. You don't get a lot of, how to say, chaotic stories out of North Dakota. It's just, just the way it is. Very high population in Florida. Highly variable weather. Not really sure where CNN's coming from that. And governmental funding. I'm sure if I read the article, it will make sense. But the idea here is that it has kind of spread like wildfire. But the important thing to understand here is that Florida does have these very lax information laws that make it easy to access information when it's available. Okay. Now, why am I talking about this? It's because of these freedom of information laws in Florida. That's the main thing we're going to be talking about here, which is that public records and the like. The general public records is that it's the policy of this state that all state, county, and municipal records shall be at all times open for personal inspection by any person. It's a pretty permissive statement, with public record being further defined as papers, letters, maps, books, tapes. You get the idea. Regardless of form, characteristics, or means of transmission, so that covers email and that kind of stuff. Agency being, and then they further define agency to be very broad as well. Now, the other idea here is that, now things like, of course, state ID numbers, social security numbers, those aren't public information. That shouldn't be released to the public. There are further records in that saying, which is important for our further discussion. Also, since we're about to discuss politics, I need to give my normal disclaimer, which is that I'm not going to pretend that I don't have political opinions. I have political opinions. But it's not my job to share my opinions with class, because I assure you that I will disagree with every single one of you on some specific point of policy enough to make you feel alienated. I'm not going to discuss politics. The reason I'm going to be bringing up this particular politician is because this is the most recent case of a politician making this mistake. Once another politician makes the same exact mistake in this manner, I will be covering this politician. Okay? So we are going to be talking about the before times, I guess, all the way back to 2016, the election of 2016. And we're going to be talking about email, but not the email you think. Instead, we're going to be talking about the Republican presidential primary of 2016 with the then leading candidate of the time, which was initially who? Anyone? Who was the initial leading candidate of 2016 on the Republican side? Not Romney. Not Romney. He was 2012. 2016 election. Donald Trump was not initially the leading candidate. Obama is Democratic, and he was also term limited in 2016. Yes. Hint, we're talking about Florida. No, it's the U.S. elections. We're talking about Florida. No, it is this guy. I'll stop torturing you. It is this guy. It is Jeb Bush. Yes, Jeb. Jeb Bush. All the initial smart money was on him for winning the presidential election. Not the presidential election, the presidential Republican primary of 2016. Okay, and again, going into that further would be, outside of this, we're going to stay focused on Jeb, who is the source of many, like Florida Man, is the source of countless memes online. But anyway, relevant here and why we're talking about him is that if you notice under his profile is that he was the 43rd governor of Florida from 1999 to 2007. Now, this time was about actually kind of the adoption and proliferation of public access to the internet, which is relevant. Jeb Bush, to his credit here, he adopted email very early on, like ridiculously early on, and used it for communicating in various functions, various ways to reach out to him. And so this is one of those early adoptions, and this is back when like the WhiteHouse.gov email site was like very bare bones. Everything on the internet was bare bones in these days. So, having a governor who was accessible by email, in the early 2000s was fairly unique. And he conducted a lot of business. So, to the point that there's a joke about him being an e-governor at some point. But it was a very, it was a very useful way to, for people to for regular people to get in contact with him. Anybody know why you as a citizen might want to reach out to a governor or representative for reasons other than to complain and reasons other than to make policy suggestions? That seems like to cut out most of it, right? Yeah? Sorry? You get free stuff. Possibly. There is always campaign merch, yes. But let's talk about their official, reaching out to them in their official role. No, not that kind of stuff. Not reaching out to them to be hostile. Yes. That's a very good reason. I wasn't thinking of that, but that's a very good reason. Alerting them to a situation early. Kind of thinking that, but not necessarily in the way you were thinking about that. So one of the more kind of interesting reasons that you might find to reach out to a government official is to cut through bureaucracy. To cut through a lot of red tape, because there is sometimes a lot of red tape. One of the reasons why one of the most common reasons why, not common, but like notable reasons why you want to do this is that if you're dead, well, legally dead, that is a pain in the butt, let me tell you. If you're dead, you can't get a job, you can't receive wages. You don't have to pay taxes, but it's hard to pay for anything else when you're not receiving wages because you're dead. You can't also own anything because you're dead, and you can't really get some help from the government services because you're dead, on paper at least. I mean, you're a living, breathing person in front of them who's obviously an impersonator, even though all your documentation says you're not. Kind of see the catch-22 here, right? It's kind of that issue. In those cases, being able to reach out to a state senator, state representative, your federal representative, your federal senator, or your governor can really help cut through red tape. And people will reach out to you via emails occasionally for these things if you're in this job, especially these days. Much in the same way that you can reach out to companies on the site that was formerly known as Twitter, to kind of get customer support directly when when calling and waiting an hour on the phone line doesn't really help you. It's a good way to kind of cut through red tape there. So keep that in mind, because it's a non-common thing, but it does happen where a person's accidentally declared dead. It's just often a bureaucratic mix-up, and nobody wants staff to fix it because that kind of implies that it's their fault, maybe, which of course not, but that's just the way things are. So back in 2015, as part of being to promote, to show, I'm super transparent, I have nothing to hide. When running for president when running for president in 2015 for the 2016 federal election, he released his emails, which is something that he would probably have to release anyway with the sunshine laws in Florida. Again, those things are like a matter of public record. The issue here is that his team. I'm not going to necessarily blame Jeb Bush here because his team really should have known better. His team released a bunch of things that they shouldn't have released. So let's go ahead and look that up. Jeb Bush email data set. There we go. Let's see. Not data set, but Jeb Bush email. No, not that. Jeb Bush email. Do I have to go for scandal because it was so small? It was like a 2-day thing on the news. Except it was, let's see. I think it was The Verge that honestly has. There we go. All the way back in 2015. Jeb Bush dumps emails including social security numbers of Florida residents online. Subtitle: Florida man strikes again. So anyway, now what happened here? This happens occasionally with. So again, this is why I say it's not necessarily picking on this person specifically. The reason I'm picking on this example is because it's directly applicable to what I'm going to teach you in this class. Like in this lecture, I'm going to teach you about like what we can do about this, which is different than necessarily other email scandals. So in a note of, he hadn't even formally declared at this point, in the spirit of transparency, I am posting the emails of my governorship here. Set a note on Bush's website. Some are funny, some are serious, some I wrote in frustration. Some also contained email addresses, home addresses, phone numbers, and social security numbers of Florida residents. Now, for those of you who are not U.S. citizens or who are international students, you may not know the significance of social security numbers. Americans have, for a long time, been against the, or at least talking from like the legislation passing perspective, there's been basically no appetite whatsoever for a national ID system. Americans don't have a national ID number. They might have a state driver's license number or a state ID number, but there is no national ID number. This is for a variety of reasons that I will not get into here, but as a result, what Americans do have is a social security number for Social Security. Now, for the longest time, these things used to say, don't use this Social Security information, number for identification purposes, and everybody then proceeded to ignore that, and now it's basically become a de facto, although not a de jure, form of national ID, which is terrible. There's entire YouTube tirades on that, I'm sure. In fact, but essentially, the Social Security number in many effects acts as a very insecure national ID number. So yeah, being able to associate your name, being able to associate a name, an address, and a social security number is a pretty good way to be able to gather, and maybe you just need to gather a little bit more information to be able to impersonate somebody online at that point. So that's why it's kind of a big deal there. It can be available at Bush's website, which if we go and click on it, hey, so, and it looks like it's just basically chyrons at this point, just kind of an auto-generated website. It's a dead link, in other words, at this point. So the reason so that's why I'm going here to a news site rather than taking you directly to the source. So We reviewed many emails from Bush, found a wide variety of communications, everything from religious parables to praise of the governor's support for creationism to routine bureaucratic correspondence. But some emails appear to be highly sensitive or personal, many like ones excerpted below. Let's see. But then over here is kind of the idea of more problematic emails. RE, name redacted, social security number redacted. This is letters to inform you of the facts regarding redacted employment at the House of Hope Orlando. Redacted is a vital part of our boys program. The moral character and integrity is not in question as we've dealt with redacted. Here's the facts about this person. So basically somebody who's, if you read this email, has had previous encounters with the law, and this is something in basically an email saying, hey, there's trouble going on, but we've been working with this person for 7 years, and we think that this trouble is unwarranted, right? But there's the person's social security number there. Another one for healthcare representative, asking for basically getting somebody, asking the governor to help please cut through red tape so that this child can get the medical care they need because of insurance reasons and stuff like that. Here is the social security ID and the medical insurance ID for this person who sent this email. So now social security numbers in particular are protected. They are both confidential and exempt from the public disclosure laws. So that, was pretty problematic, and, and what they did was essentially they just, quick to shift blame to the state, saying it's an exact replica of the public records on file with the Florida Department of State. But, again, it's been stripped of that stuff. And, you can pour into this if you want, but that's neither here nor there. What we want to talk about is, suppose you have the job of releasing a giant data set of things, and you want to strip it of personally identifiable information. And there's a gigabyte of text. And for context, right, the complete works of Shakespeare was like 5 megabytes of text, so good luck here. What can we do? Your boss thinks you're a computer wizard, so you got to get it done, right? Somehow. And, going through and looking through social security numbers, okay, maybe I could write a for loop that checks every single possible social security number. And we're just going to focus on social security numbers right now. Maybe writing a text program that goes through and looks for every possible social security number might work. It's also going to take a really long time, and it's really not going to help. Also, if you think about how to write an if-else statement just to make any kind of look for, just social security numbers in general, just do a rolling search, okay, is this string a social security number? All right, I have to look through the text and find until I get to a digit. Then I have to check if the next character is a digit. Then I have to check the next character is a digit. Then I have to check if the next character is a dash, and all that kind of stuff. So it gets a pain. But fortunately, with the power of regular expression, if all you're trying to do is remove social security numbers, then guess what? All you need is really one line of code in Python. And that's kind of the power of regular expressions. Regular expressions are these kind of things where if you will take the 2 hours outside of class to learn this, your life will become a lot easier at random points of your life. It is a very useful task. So what are regular expressions? Regular expressions are a subset of language, basically a subset of, is kind of a miniature language, I guess you could say. It's a way, but in this context, it's a way for matching text and finding text. For instance, here is a regular expression search on this pattern over here. And let's not focus on any of the slashes and just focus on this bit, which is basically what that translates to is an H followed by any amount of vowels. So it finds both the HEs in the HEA in heaven, a lot of those, but it basically hits all that. It also finds the HE in there, the HA in that. These are pretty valuable things. Okay, they are extremely powerful tools for finding and matching things in text. You can use them to to match emails ostensibly, although doing one that hits every single email is a bit difficult, let me tell you, because emails can actually be way more lax with their rules about usernames than you think. How many of you have Gmail accounts? Yeah. Okay. Try sending an email to yourself, and try putting dots in random places in it. So, for instance, I've got a Gmail account, and let's say it's andrewrosen@gmail.com. It's not, but let's say that. I could do it as Andrew Rosen or andrew.rosen@gmail.com or a.n.d.r.e.w, and they'll all go to the same person, which is me. Okay. Also, if I want to hand out my email to a website that might give me spam, I can say if I did Andrew Rosen plus this plus symbol, don't spam me @gmail.com, that will also go to me. And I'll be able to see that they use that address. By the way, the plus symbol is perfectly valid in email addresses. This is what I mean. Like, email addresses can be very lax with their rules. It's very interesting stuff. So you can use regular expressions to basically remove ID numbers. You can use it to find email addresses, to remove telephone numbers, and in this case, social security numbers. Okay, we're going to be using regexer. I suggest using regexer. So REG. This website, REG EXR, for doing this. It's a pretty great tool. It also has ideas. It's got a pretty good reference on how to use regular expressions and stuff like that. And over on here, you build your regular expression, and here is the text you will test it on. So for instance, I might say hi, let's see, Professor Rosen, I'm having trouble signing up for your class. My name is Alice Adams, because A's, and my social security number is 123-456-7890. Hopefully that's not your social security number, but if it is, I'm very sorry, I just doxed you. Well, not. But anyway, so social security numbers for the most part are in this, social security numbers, of course, are not in that format. They're in this format there we go, 6, 7, 8, 9. They are 1, 2, 3. They are 3 numbers followed by 2 numbers followed by 4 numbers with dashes in between typically, although sometimes not. I hope you can help me. Thanks. Okay, so there we go. So that's an example thing. Now, how can and suppose this is just one of many emails that I get, and I want to sift through all of my emails and remove any that have social security numbers in them for some reason. I don't know why. Students never sent me their social security number like that. But again, we have to have some example of some kind. Okay. Now, over here is where we build the regular expression. Ignore these for right now. This basically just simply says start and stop of regular expressions. For the most part, my plan today is to teach you how to use basically teach you a bit of the grammar today. And then we're going to talk about how it integrates with Python on Thursday. Okay. So the fun thing is that regular expressions exist in every language, from Java to Python to C++. Maybe not C, although I'm sure somebody built a library for it. I'm just sure it's not built into C because nothing is built into C. you have to basically build everything in your C yourself or import it. It's a very minimalistic language. But pretty much every language that you would expect that you could name these days supports regular expressions. It's that useful. All right. So the idea here is that when you do a normal find replace, if you were to search for the letter, if you were to do Control F on the letter S, it would pop up with all this stuff. And regular expressions works in the same way, where basically if we ask for the regular expression on the letter S or a specific letter, it's going to find it. If it's T, if it's N, if it's the number 4, if it's a capital T, it's going to get the capital T. It's case sensitive, so we can see that. So nothing too exciting yet. If I want to look for if I want to look for a period in this, it's going to look like this. Oh, wait, what? So period is, so there's actually, so for the most part, all the letters work and all the numbers work. Some of your commas, your punctuation, that has special meanings in regular expressions that we'll get into. But one of the main advantages of this is character classes, the ability to look for more things, more than one thing at once. We can define our own character classes by using brackets here, which I'll go into more detail in a bit. But like if I want to look for any vowel, I can say this, A-I-O-U. And now it highlights any vowels. And notice the addition of these brackets over here. The bracket, and this is why I love regexer. It says character set. Once I put the brackets around, I identified it as a character set. Match any characters in this set. Pretty good, right over here. So these are powerful. Now there's some built in here. But we'll go ahead and skip ahead to doing this problem. One of the built-in character sets there's 3 built-in character sets. One of them is this one, which is the one we need for the problem, which is /D. And notice that all the numbers lit up. /D is fairly straightforward. It's /D for digit. /D for digit. And it found all of them. But so it found all these numbers. Let me go ahead and add some more. My TUID, which is probably more useful here, is 1, 2, 3, 4, 5, 6, 7, 8, 9, or however many it is. Doesn't really matter here. What a coincidence that those match. But what we want to do is we want to be able to write a program that's going to be able to find this and not this. So /D matches any single digit character, a 0 through 9. So you might reasonably assume, and correctly so, that doing another D and another D would match 3 in a row. And we see that. We match 3 in a row over here, we match 3 in a row over here, and then we match 3 in a row over here, here, and here, right? Regular expressions are fairly simple. Once it matches, it doesn't, by default, it's not going to do this overlapping subset matching. It's not going to match, it's not going to return 6, 7, 8 as a match and then return 7, 8, 9 as a match, right? It's going to just do 7, 8, 9 and continue from where it left off. Because if you think about it, you could go either way, and they prefer to do the one that seems to be more straightforward, least computationally complex, which is as soon as I find it, I'm going to say I found something that matches this and then continue on from that point. Everybody get it? Okay. So now dashes work exactly as you'd expect them to. So if I wanted to find 1, 2, 3, find 3 numbers followed by a dash, all I have to do is say /D, dash, and then you can pretty much figure out the rest here, which is that /D, and then /D. And that's it. That's all you have to do to find a regular expression that's all you have to do to find Social Security numbers with regular expressions. That's it. Let's see. Python regex. Okay. Oh, sorry, I locked that. Sorry, that was locked. No worries. Okay. So Python regular expressions, of course. This is, you import RE to use any of these. RE for regular expressions. And Control F, replace. Let's see, I think it's replace. Oh, no, it's sub. And there's your command. Basically, this is the one that's relevant for the exam, which is pattern, replacement, string, saying, hey, I'm looking for this pattern. The pattern in this case is this over here. I want to replace it with this string, like maybe redacted or something like that, or removed, or an empty string. And then string is what you want to search for. And everything else after that is optional, saying maybe you only want to replace so many for some reason, or other flags like saying, hey, I want to do this search case insensitive. So let me tell you what the regular expression on the final exam is going to be. Okay, just to give you some incentive to learn this, because of course you could completely just simply say, I'm stepping out of this lecture. I don't need to learn this because it's all extra credit. It's an optional question on this. So let me incentivize you by telling you what the question will be. I'm going to give you a file, and I'm going to ask you to remove all of something from a file, either a phone number or a email address, or maybe like a made-up kind of ID number. Like I've done healthcare ID numbers before, So doing that, I've done removing email addresses, I've done removing phone numbers, but something like this. Now, that may sound scary, but as we'll see on Thursday, that requires about 7 lines of code at most, including your import statement and your file reading statement. It's actually very short if you take the time to learn your regular expressions. So it's kind of a free 20 points on the exam. So I urge you to basically take the time to study it. And I urge you to go, and this is where the second textbook that I have listed in the syllabus comes up. The Automate the Boring Stuff in Python. Chapter 7 in that book, even before it goes into reading and writing files, goes over, as soon as he teaches you strings in that book, he goes over pattern matching with regular expressions, because that's useful for anybody who's learning programming. And it goes over how to do this in Python. And he goes, okay, so like for instance, this is how complex it is to write a program that finds a telephone number if you're just using, regular programming and not using regular expressions. Whereas with regular expressions, it becomes a lot easier. And he goes through the formal way of compiling regular expressions and then searching for a match object, which you don't need to do. I'm going to just basically I'm going to keep it simplified on basically, here's a file, let's go and look for everything in the file, / let's go and replace everything in the file. Okay? Because the writing the regular expressions is the more difficult part, that's the more novel part, and the more difficult part, and that's also what's transferable to other languages, because every language does it slightly differently, But the regular expressions, that's what matters. Okay? So, right, and so that would have, saved about 2 days of negative press, I guess, which nobody remembers but me. But now you're all forced to remember it forever now too, I guess. So, again, it's nothing to do with that. I just love being able to start the conversation by saying, hey, who knows about Florida Man, to start teaching this stuff. Now, with regards to, so this would find me this number over here. Of course, what if they decided to say my social security number is, they decide to separate it by spaces for some godforsaken reason? Well, fortunately, regular expressions are pretty darn good at that. Let's go ahead and do the example of maybe they're all one number first. Okay. Well, we already know how to solve this one. So we will solve it first, actually. Oops, 1, 2, 3, dash 4, 5, dash 6, 7, 8, 9. Which is we can make a character set of our own, saying, hey, followed by either a dash or a space, followed by a dash or a space. Making your own character classes is often good. But what if, again, if they decided to, just have so that works there too, even if they're really weird about it. What if they decide to make it a single big number like that? You know. And this is where, I told you about how punctuation marks have, special meanings here. So, for instance, the question mark over here means that the preceding thing is optional. Here, the thing that I'm talking about is a character class, right? Quantifier, mapped between 0 and 1 of the preceding token, right? So it says that the dash or the space is completely optional now. Make sense? Now, mind you, we're getting false positives now, but I'd rather get false positives, which is I'd rather redact too much than too little in this case. So let's go ahead and talk about just the generalized tools that we have here, right? So first off, we have just, you can look for any set of characters, A, B, C. It's not going to match A, it's not going to match B, it will match A, B, C only. It's going to look for all those three characters, it's going to look for that specific string. There are some operators we can do. There's various operations we can do here as well. But first let's learn about the other punctuation mark of note, which is the dot, which did weird things. Okay? The dot character is the wildcard character, meaning it matches anything. So that's why when I had it by itself, everything lit up. In regular expressions, it matches anything, and I do mean anything in your text. That's great when you're trying to look for something like we had on the practice exam, like the wildcat problem, where I said, hey, look for the string cat, but the middle character can be anything, right? That's exactly what we'd be doing over here, where basically I'd be looking for that. So that will match both cat and cat, or cat, like that. Right, it'll match. So there, the dot will match any of those middle characters. It's a pretty useful tool. Okay. What if I need to look for an actual dot, though? Like, what if I'm looking for actual punctuation marks? Any guesses what you need to do? A hint, it's the same thing you need to kind of do in a program with strings here in Python. Yes? Not quotes, but you're thinking in the right direction. Yes? Brackets? Oh, you could do brackets. Yeah, you could totally do brackets. You're thinking around the box here, and I like it when students think around the box. Although it does say match any character in set here, so we need to use escape characters at this point. So slash period to say, hey, I actually want to look for this dot. Here, let's see, does that work here? Yes, it does. That worked. The brackets dot worked as well. I just scrolled too far down. Okay, so that's one way to do it. Another way to do it over here, that's perfectly fine. And that's pretty much it for those characters over here. There's a few there. I'm going to teach you about the clean star and the plus quantifier in a bit, but I want to talk about other characters first. So first, let's go ahead and look at some other characters. Okay. Specifically the other character classes. I've already introduced you to /d, which is digits. And every character class that's built in has an invert to it. In other words, find the opposite, which is very easy. Easily confused, but it's also easy to fix if you confuse it. So to find anything that's not a number, not 0 or 9, you just do the capitalization. Make sense? I mean, not really. You'd think it maybe should be like, some other symbol or something like that. But lowercase for the character set, uppercase for the invert of that. And I mean, you can see that built in over here if we were to go check out our references over here. Right? It teaches you how to do these things, which I'll go into in a second. So here, word, digit, white space, not word, not digit, or not white space. So let's go over those other ones. /W is another really common one. It searches for word, which basically means, and here it's kind of this, I would define it as anything that could be part of a variable name. So not spaces, not periods, anything that could be part of a variable name. So your letters, your numbers, and underscores. Like that. So, and once again, to find the opposite of that, which is going to be surprising what that is, or mildly surprising what that is, we capitalize it. And we see it's punctuation and white space. That's not part of that. Now, this one's one that I'm very fond of over here, and you'll sometimes see me use it. I made in some assignments or other videos I do, which is /s. And that one's very useful for when you're doing the split operation, because that searches for white space. And it doesn't matter what the white space is. It could be, that's both your spaces and your tabs. It'll search for it. So that's pretty nice. It searches for any white space. Okay. Now, one of the other, but typically when I do that, like if I want to split on white space, in Java, not Python here, but Java, I often use this for the split operation in Java. But if I want to find like a sequence of white space that's super long, basically as long as it can be, then typically, then this isn't going to cut it. This finds every single white space, but it doesn't like find an entire chunk. So now the final two operators I really need to teach you before we can really start getting into stuff. And the way we'll start getting into stuff is I'll take a look at what the homework is, and maybe I'll start solving some of those on there. Okay. So let's take a look at the plus operator. And it's a very subtle difference what happened there versus not having it versus having it. Well, that's not subtle, but this over here is subtle. This is now a single thing that it found. So the plus operator is one of those quantifiers, like the question mark. It's one of three that we use here. The question mark meant 0 or 1. This means one or more. In other words, at least one of. Okay, at least one of. Okay. So over here, what we're saying is, so we saw that also in the Wikipedia page where it was looking for at least one vowel. So this looks for at least one white space. We can use that over here, again, to look for at least one vowel in a row. A, E, I, O, U, we made our own character class, and plus. And now it identifies OU as a single string rather than O and U separately. Make sense? It's identifying it as one chunk. So it finds any string that is at least one vowel long. Any string or substring. Any string or any part of string that is one vowel, at least one vowel long. The last one's kind of weird. And I'm going to have to use, and honestly, the only way I can really help explain it is that I have to kind of resort to kind of, I guess, internet speak. So, O and, so L, O, and then star L. So clean star, KL, not clean as in your room is clean, but KLEENE, and named after the guy, one of the guys involved in the invention of regular expressions. The clean star, or just the star because very few people remember what it's called, is the 0 or more, which is kind of weird if you think about it. So but let's take a look at what it matches. It matches LOL, it matches LOL, it matches LOL, it also matches LL over here. So it says 0 or more of that middle one. It's one of those things that you don't really have an immediate use case for. It's really helpful for the formal part of regular expressions when we're formally proving stuff about discrete finite automata. But here, it's more of those, oh, this is the tool I rarely reach for, but when I need it, I need it. You know, the kind of thing over there. Okay? So that's what that one is useful for. Those are your primary quantifiers. So let's go ahead and open up Canvas and take a look at our home at what I gave you for this. And how much do I care about this? Well, I give it as extra credit in my data structures class as well. So, you know, that's how much I care that you learn about regular expressions. Also, it's time to fill out your student feedback forms. Yes, those do actually matter for your professors, by the way. Not only do we read them, they are kind of tied to, like, you know, any evaluation that gets done. So we can, so, you know, we do, but for me, personally, I do read them and I do make changes to my course based on what I see if I get a lot of students saying the same thing, you know. So I do definitely want to know what you feel, how you think, and those kind of things. They do matter, and we do read them. And computer science typically has a low response rate, so we'd love to see if you did that more. Again, it does matter. Okay, so right over here, regular expressions. Where is that? Do I even have? Yeah, I do. Over here, it says 0 points, but if you click on it, I'll move it over here to final project. Oh, if you click on it, how much did I say? So this is under that. How much should I make it work? You know, I'll make it juicy. Let's go with 30 points. That seems pretty juicy. That's fairly substantial. That's like an extra third of an assignment. Okay? So over here, you've got two files. One is words.txt. If you've got a Mac, this is built into your computer somewhere on your computer, or a version of it is. It's your dictionary file. By what I mean is that it is literally the list of words that is used for spell checking in your for a bunch of your applications. That's what your dictionary file is. It exists in some form on Windows as well. I just don't know where. In Unix, it exists in a specific place, and you can find it. But here, I provided it for you, so you don't have to go searching for it. Why? Because we're going to be parsing this file, this file of words to ask questions about words for this, and using regular expressions to answer it. It's a problem in 4 parts. Part of one of which we already kind of did, so already there. One of which we actually did as an in-class exercise, so maybe that's even more of an incentive. So for the first part, what you do, it relies on that words file. What we want to do is that we want to parse this words.txt. If you're using a Unix system, if you're using a Mac, you're using a Unix-based system. If you're using Windows, you can install one on a Unix-based system on your Windows device, because Windows Subsystem for Linux is a thing, and I love it. It's awesome. So feel free to use the dictionary file included on your computer. Some words begin with capital letters. Please include each regex with your answer. By the way, because some of the questions can be interpreted ambiguously, it's less the number that I'm concerned about and more the regular expression that you use to find your answer. Okay. I like animals. How many words contain the word cat or dog in them? So basic regex over here, just use cat or dog, right? It's fairly straightforward. 4-letter words are supposedly naughty. How many 4-letter words are there? In other words, how many words have 4 letters or more? So far, we haven't strayed far from being able to solve this with using what we know already without using regular expressions. I'm scared of pyramid schemes and MLMs. How many words contain the word hun in them? Now finally over here, we're getting into the points where regular expressions are starting to get more and more necessary. Do more words end in ing or ion? Again, a lot of these can be answered without regular expression, but we want you to use the regular expressions to get practice on these problems because it's also fairly easy to check. How many words contain a Q not immediately followed by a U? And in case you're curious, that's words like Iraq, you know. So how many words have no vowels? How many words are only vowels? How many words are contracted with not, meaning they end with, and I think this is a misspelling, they should be ending with N apostrophe T, like didn't. How many words with two vowels in a row are there? How many words with at least two vowels are there? The vowels need not be adjacent like in the previous problem. Now first off, regular expressions are a type of regular language. Being a regular language means that they are a subset of Turing-complete languages, which are programming languages. That's all a bunch of stuff for future classes, which is to say that regular expressions are technically unnecessary, right? You could do all these questions without using regular expressions. Your job becomes just a lot easier when you're using regular expressions to do this, okay? So if you're having trouble, please see this link, which is a link to regexer. Then just some other stuff that you want to read the chapter on. Just as a warning, the author is very fond of RoboCop jokes, so he has a lot of RoboCop examples. That's not so much a warning, I guess. It's just an amusing point of order. So like, how would you write a regex that matches the full name of someone whose last name is Nakamoto? So it must match the following: Satoshi Nakamoto, Alice Nakamoto, RoboCop Nakamoto, but not the following: lowercase, Mr. Nakamoto, where the preceding word has a non-letter character, Nakamoto, where there is no first name, where Nakamoto is not capitalized. This number 3 is probably the biggest pain, which is create a regular expression that matches the strings 20, 21, 22, 23, 24. And then create a regular expression that will match dollar values, such as the following. So 100, 10,000, 1, 2, 3, 4. And obviously I don't want you to... So first off, when I say that will match these, I don't mean like overmatch. You want to get as specific as possible with these. So let's see. So let's take a look at one of these problems, like over here. So over here we have a words.txt file, and let's just go ahead and get that on my desktop to start up with, and let's go ahead and open VS Code, because why not? See. Don't save. Ooh, what was that? Okay. So, first thing we'll want to do, we've only got a bit of time left, but the first thing you want to do to be able to work with regular expressions is to import RE. Okay. And let's go onto the desktop. Don't call it, and again, don't call it file turtle. You don't want to call this RE. Maybe call it regex homework or something like that. .py. So import RE to import regular expressions. And then, of course, to read a file, we already know how to do that with open words.txt, right? That's the Word file. Use the read mode, and let's call it maybe data or whatnot. And then we already know how to then we can decide how to read it. How to read it depends on what we're doing. Here we're just doing matching, so I feel like going line by line is perfectly fine, right? So saying for line in data, and that's just going to read our line, no problem. I'll put in pass for a second. And then what I like to do is I like to build my regular expressions outside in its own thing. And what we're going to, and I call what we're going to be looking for the pattern, okay? So let's go ahead and say I want to look for, again, the word. What was the first question, right? It was how I like animals a whole lot. So I want to find all the words that contain cat or dog in them. Oh, that gets into a thing over here. And that would look like something like this. Cat or dog. Let's see if that works. Cat, dog. Yeah, that works as intended. The bar is used for or. Single bar. Where in the world is that character? I've never seen it before. It's the pipe. It is shift, and then it is on an English keyboard the backslash key. That key. Shift and that on an English keyboard. You'll use it a lot in Python because this is how you do or in Python, and this is how you do, not Python, Java, and this is how you do and in Python. I was saying Java. Yeah. So here we use that straight line. So I would build it like this, cat or dog. And that's it. To say this is the pattern I'm looking for, and then we would use the RE library. Now we could use objects for this, and I always have to look this up the first time. But I think find all should do it. Find all. No, not find all, because we're going line by line. Let's see. Yeah, actually, why not? Text is equal to data.read. So I'm just going to read this entire thing into a file. Sorry, into a giant string. Make one big giant string of it. Why not? Why not? Why not make it just one string? And then answer is equal to re.findAll. I forget what it does. Oh, it returns a list, doesn't it? Find all that have the pattern. Let's see. What am I looking for? It's pattern, and then we're looking for it in the string. Pattern in the text. This is what I mean about like answers with regular expressions being extremely short if you count the actual number of lines here that we're doing. Print len of answer. And then, well, actually, let's go ahead and print our answer first to see what we're getting. And there we go. And it's just going to come up with a lot of cats and dogs. Oh, just search for a lot of cats. I bet you what it was doing was it was looking for, so I bet you it was, oh, no, it found dog too. There we go. Turns out cat's pretty common, right? Dog's not so common. Let's see. Now, if we wanted to do this one at a time, I would have to, let's see, substring occurrences in this. Let's see. How would I do that? Cat or dog /w plus star. I'm just messing around here. I'm looking if I can do something here. Okay. Yeah, it's the same thing. But I want to print the same. But how do I get the entirety of the word in there? How do I get the entirety of the word? I don't know if I can with just find all. Control F, find all. Okay, match object there. Has groups. Oh, yeah. What am I doing? I don't need that. I don't need the groups. I need unbalanced parentheses. Oh, there we go. Oh, and then Predicate, oh, okay. And then yeah, now I know what we need. Okay, there we go. So I'm just curious as to what the words were. I wanted to be able to get the words there. So let me go ahead and explain what I was doing. So what I wanted to do is I wanted to print out the words that I was getting to, as opposed to just finding cat or dog, because that's what it will do. So what did I do? I said, hey, if there were any characters before cat, I'd like to print them out. If there were any characters after cat, I'd like to print them out. Or I'd like to get those characters too, right? So, and if there's anything after or before dog, same over here, right? So here this said, okay, this is a letter. There's a bunch of letters before cat, then we have CAT, and then we have ION, right? So that just simply it doesn't change the answer as far as the number, which is 413 words, right? What it does change is just simply printing out what is that. It allowed me to kind of get what the words were. But I also just want to emphasize, so first off, the answer that we would have gone for initially should have been this, which was just simply pattern is equal to, again, cat or dog. That's the one I would have wanted. But the point being is that look at how short the program is. That's literally all the program is. Regular expressions allow you to be very concise with what you do. Okay? So on Thursday, we will learn more about this concept, and we'll learn about how to apply it better. Stay healthy and stay safe. It's a bit of there's, I think, a bunch of sickness spreading at the moment. What? I did.